Our next speaker is Dr. Rory Monaghan from Galway. As I said, Rory leads our decision support tool and moves that forward. We have a bit of feedback, and all the other presenters, please go on silent, please. Rory's going to look in today's webinar exploring opportunities specifically in the Northern Ireland energy transition. Rory was the lead author along with James and Ian in the work that was done in the report for Northern Ireland, was commissioned, as Thomas talked about earlier. Rory is the lecturer of energy engineering in the School of Engineering at the National University of Ireland, Galway. He is the lead energy research centre in NUI Galway Ryan Institute, a funded investigator in MARI, the Science Foundation Ireland Research Centre for Energy, Climate and Marine, and the director of the Energy Engineering Programme at NUI Galway. Rory has been researching hydrogen and fuel since 2003, when he commenced his graduate studies at the Massachusetts Institute of Technology. Rory currently leads the long-term effects work package in our GenCom project we talked about. Rory is also leading the next work package, which is the enabling support tool, moving from decision to enabling to stimulate the market and use hydrogen as the catalyst. It has been funded under the Interreg Northwest Europe programme, and Rory was commissioned by the Department of Economy to prepare the think piece on hydrogen opportunities in Northern Ireland, which he's presenting in today and laying out the map as we move forward. Rory, over to yourself. Thank you very much indeed.
Thank you, Paul. Thanks for that very nice introduction, and thanks everyone for being here. Now, I'm not sure if other people's screens are perhaps, Paul, I could ask you, is my text going off the side of the screen on your monitor?
No, everything's okay. Your slide.
No, it looks okay. Okay, I'll just go ahead with it then. Okay, so I'm going to present the results of a study that NUI Galway, with partners from Dublin City University and High Energy, were commissioned to perform over the end of last year and the beginning of this year. And as someone who was raised in Galway, but to parents both from Northern Ireland, I must say it was great to have the opportunity to do something that can benefit Northern Ireland, I hope. So the final report was delivered last month. It's available on the GenCom website, so I'd encourage you to go and have a look at it. It's about 20 pages. It's got lots of appendices in there to help explain some of the basics of hydrogen technology. So hopefully it can help sort of people understand what the whole hydrogen opportunity for Northern Ireland is. I'm going to summarize the results of that paper today. So I'll talk about some of the key technologies, which of those technologies are suitable for Northern Ireland. I'll focus then on the policies. I guess this has been touched on mostly by Ian. I'll look at some of the key policies in UK, Republic and EU. And when I say key policies, I'll say key policies or lack thereof in some of the key jurisdictions. And then I'll take you through the core really of what our report was, which was identifying 2030 hydrogen scenarios for Northern Ireland. So I'm not going to show you the big picture hydrogen as core part of an energy system work that James Carton showed you. You know, what I'm going to show you is the first steps into hydrogen. James really hit the nail on the head there when he talked about the next decade being key. So we're trying to show how within this decade we can make some measurable progress on hydrogen in Northern Ireland and identify some key locations and key sectors to go after. And I'll finish then with a summary of how that fits into the bigger picture. So again, I'm just going to see if I can get just change my screen here a little bit, because my slides are falling off the side of the screen. Okay, it looks okay for me now. So this is a summary of the technologies. So up at the top we have the hydrogen production routes, and as James as Ian mentioned, the two main routes under discussion now are the green route, which is favoured by the European Union, and the blue route, which is being looked at strongly within the UK. In storage and distribution, we can think of hydrogen being moved by three main routes. We can move it as a compressed gas. If we do that, we can benefit from the industrial gas network that moves gases around at high pressures every day. We can start to identify opportunities within the gas grid, And we can look very interestingly for Northern Ireland at the salt cavern concept of large-scale hydrogen storage. If we're moving larger amounts of hydrogen longer distances, we can look at cryogenic storage. This involves not compressing the hydrogen, but cooling it hundreds of degrees below zero so that the hydrogen becomes a liquid, becomes very dense, and can be moved cost effectively. And then there's this emerging area of work, which is chemical transformation. So converting the hydrogen to another chemical that can move the hydrogen at very high density. And now there's, yeah, as I said, that's an emerging area of research. And in terms of the overall end use applications, it can be used across the board: transport, heating, power, transmission and storage of energy, and as an industrial feedstock. But for the purposes of our study, we're identifying this key route coming down the left-hand side of the graphics for Northern Ireland. Northern Ireland has got enormous renewable electricity resources. It has salt cavern storage and a very modern gas grid, and it has had challenges so far, as have many people working on the transport and heating decarbonisation. I've left the blue route here in dotted lines because there is almost certainly going to be some interaction with blue hydrogen from Northern Ireland, just given the direction that that the UK as a whole has taken. And given the strong gas interconnection between Northern Ireland and Great Britain, there will be some interaction with blue hydrogen. So I've left this in for now. Okay, so I won't go into much detail about the electrolyzers. Ian talked about them, but they are scaling up. And what I'm going to be presenting to you is electrolyzers that are within the bounds of current electrolyzer technologies. The case studies I'm showing don't rely on any new technology to be developed or any major scaling up of existing technology. We're just talking about what are the practical low-hanging fruits for Northern Ireland. Steam methane reforming is how about 90% of the world's hydrogen is produced today. And when you combine CO2 capture with steam methane reforming, we have what's called blue hydrogen. And as I said, this is being considered in the UK, and it's there's a number of projects being brought on stream benefiting from the UK's large-scale natural gas resources under the North Sea. And this is really being seen as a bridge for hydrogen production to the future, where it would be predominantly green hydrogen. Salt cavern storage, again, just to summarize, because we're going to refer to this later. There's salt cavern storage being identified within Great Britain, and there are conversations underway to see how this would fit into the Northern Ireland context. And again, just keeping in mind the location of where these salt caverns are, in the vicinity of Belfast, near where the gas interconnection with Great Britain comes from, near where the electrical interconnection with Great Britain comes in, and also near the coastline, where there could be deployment of offshore wind farms in the Irish Sea between Northern Ireland and Scotland. It's really in a very, very exciting location. Another key technology in the mix is we've talked about hydrogen production and hydrogen storage. Let's talk about hydrogen end use. Buses, urban buses in particular, have been the big first large-scale user of hydrogen so far, and there's a number of technologies out there. And right up there at the top is Northern Ireland's Wrightbus, and that's the bus identified in the middle picture here. If you've got good eyesight and look really close, you'll see the word Belfast is written there. This is one of 3 hydrogen fuel cell double-decker buses that is currently driving the streets of Belfast. This is I'll talk more about that project later. And again, for the truly eagle-eyed, you'll see that there's the Bus Éireann logo on the side of this bus, and this is a single-decker Caetano bus that James Carton was involved in bringing to Dublin for a 2-month-long trial. and that's led to an expanded pilot operation now of 3 Wrightbus double-deckers in Dublin, which will be starting any day now. So there's a number of other manufacturers out there, but I just wanted to highlight some of the key ones. Down at the bottom here is a particularly exciting opportunity given how intercity transport is done on the island of Ireland. This is the first prototype hydrogen-powered coach by Dutch company Hyzon, and they're developing these in a joint venture with an Australian manufacturer. So the technology is moving along. And this is just an illustration of not only is the technology moving along, but cities are moving with them. There's an excellent review here, and these slides will be shared with all participants, but there's an excellent review of the state of hydrogen buses and showing how there's about 4,000 worldwide. There's only about 150 in Europe, but that number is increasing very, very quickly. And this is an example of some recent developments in Aberdeen, which is probably the leading city for hydrogen fuel transportation right now. Just re-emphasizing what the EU's position for hydrogen is. Paul McCormick mentioned this, that there is a prioritization of decarbonisation strategies where, quite rightly, energy efficiency is top priority. The cheapest form of energy is that which we don't use. Circularity, which means deriving energy from waste products, and essentially reducing the amount of waste in society overall, not just energy. Direct renewable electrification, so personal mobility, domestic heating, new build homes, all of these are suitable for direct renewable electrification. And then for those sectors that are hard to decarbonize with electrification, efficiency and circularity, we have the clean fuels. And most of these are based on a building block of hydrogen. So these would be fuels like sustainable biofuels, all of which need to be hydrogenated, using pure hydrogen itself, using fuels in conjunction with carbon capture and storage. So this is essentially the hydrogen route, and this would be for maritime, aviation, industrial heat, heavy duty transportation, heating, but for buildings that are not new, heatings that are for buildings that are maybe not suitable for the depth of retrofit that heat pumps require. So this is supported at a European level. And as Ian said, it's the European Union plans to have 40 gigawatts of hydrogen production by 2030. And that is about 7 to 8 times peak electricity demand on the island of Ireland at the moment. So a significant amount of electrolyzer capacity for the continent by 2030. Looking then at the key jurisdictions for policy. So Northern Ireland is obviously at the interface between the United Kingdom and the European Union, and so policies in both jurisdictions become important. The European Union has really targeted green hydrogen. Now, there's still the role of blue hydrogen is certainly recognised, but it's really in the UK that blue hydrogen has got more of a central role in energy planning and decarbonisation planning going forward. When I talk now about our case studies, our scenarios for Northern Ireland, we're going to be focusing exclusively on green hydrogen, because in our opinion, when we were writing this piece for the Department for the Economy, Northern Ireland really just has so many natural advantages in terms of green hydrogen that to us, adopting blue hydrogen within Northern Ireland itself would maybe not be playing to those advantages quite as well. So the key scenarios that we're going to focus on is a heating decarbonisation scenario and a transport, or a couple of heating decarbonisation scenarios and a couple of transport scenarios. Why heating? Why transport? Well, heating, we have a very modern gas grid, both within Northern Ireland and across the island of Ireland, where the distribution network, the last few kilometres up to everyone's homes and within towns, is all plastic. And plastic piping can handle 100% hydrogen. Now, that's not to say that we can put 100% hydrogen into the gas grid right now, but because there are meters that would need to be changed, gas flow is typically measured, gas consumption is typically measured with volume flow. And since the energy content in hydrogen is very different from the energy content in the same volume of natural gas, those would need to be changed. Burners would need to be changed, but the piping infrastructure itself is adaptable for hydrogen, is suitable for hydrogen. On the transport side, then we have buses are widely used within Northern Ireland and the Republic. They're the main mode of public transport in both jurisdictions, and these are also the use case for hydrogen that is the most developed worldwide. The hydrogen buses, as I talked about. There's also the local advantage of Wrightbus being one of the major manufacturers of the technology. And then we're also looking at as a subset of the transportation scenario, we're looking at train transport. And we are identifying specifically the Dublin-Belfast enterprise line as being a line, a frequency of use that is suitable for the hydrogen technologies that are being developed now. And this picture is just showing the Alstom Coradia Island train, which is a former diesel train, which has now been, they've changed the manufacturing process, and this is now a hydrogen fuel cell train that has been running very successfully in Germany, Austria, Netherlands, and there's similar technologies being tested in the UK at the moment. So what are our scenarios? We've got 3 families of scenarios. The first one is distributed hydrogen production. Now, why are we talking about distributed hydrogen production? Well, this is the way that current support for green hydrogen as a transport fuel pushes developers. In order to qualify for the renewable transport fuel certificate, the RTFC in the UK, hydrogen needs to be verified to be green. And how it's verified to be green is that it has to pass 2 tests, essentially. The first test is it directly connected to a source of renewable electricity? So that really pushes hydrogen production for transport out to the site of electricity generation. So that's really what this scenario is looking at. The second condition that green hydrogen has to pass to get RTFC support is that the electricity supplying the electrolyzer has to be additional. That means we can't be taking electricity that was otherwise going to the grid. So we're basing our analysis here primarily on the use of curtailed electricity. So curtailed and constrained electricity that doesn't get onto the network because of local or nationwide grid constraints. The second scenario is try and benefit from economies of scale. We're going to see when we look at the distributed analysis that producing hydrogen in many, many small scale locations is quite expensive, especially when we start to factor in transportation costs of getting hydrogen from these remote locations to some use center. It starts to get expensive. So what if we did it regionally? So we've identified the region in Northern Ireland up around Derry and the North Coast, where we have the best wind resource. We have a grid that is potentially not as strong as it could be, and enables the use of some of the dispatch down, the curtailed and constrained electricity. In this scenario, we are identifying 2 sub-scenarios, one where the hydrogen is brought towards Derry to fuel trucks and buses, and another where the hydrogen is injected into the North Coast gas grid and used to supply from the North Coast between Coleraine, Derry to Lifford. Sorry, Strabane, wrong side of the border. And then the last scenario is what we're calling centralized. And this is really benefiting from this geographical advantage that I spoke about earlier. Salt caverns, proximity to Belfast, proximity to gas and electricity interconnectors, proximity to potential future offshore wind farms. So how did we estimate the demand that would be required for each of these scenarios? Well, we looked at fleet turnovers. This was really where James Carton's expertise in Dublin City University came in. James is, as I see he's posted there, is working with transport haulage companies, trucking companies, working out their ability to move towards hydrogen as part of a decarbonisation strategy. And we looked at fleet turnovers, the impact of diesel bans, and used some projections coming from the EU of fleet turnover. And we come up with high, medium, low scenarios for the turnover of urban buses to hydrogen in Northern Ireland, which is this top graph, and in heavy duty 40-ton trucks. And we picked these technologies because they are available right now. Within the gas grid then, we looked at offsetting 5% of the gas usage within the northwest between Coleraine and Strabane. Strabane is currently being connected to the gas network, and then also 5% in the Greater Belfast area. And these statistics were all available for 2019, so we used those to scale our demand. What our work then, which has been developed as part of the GenCom project, is on building up the hydrogen value chain. So putting together our scenarios for supply, putting together our scenarios for demand, developing the value chain, and developing costs, developing decarbonisation, carbon abatement numbers. And we can optimize this, and we come up with an end delivered cost of hydrogen when we include everything from the capital expenditure, the operating costs, etc. So this summarizes our end results, and I'll put some of these numbers in context for you in a moment. When we look at the distributed scenario, when we're generating hydrogen at wind farms across Northern Ireland, we end up with a large number of quite small electrolyzers, so around the megawatt range. And this gives us hydrogen production costs on the low end, which are very, very competitive. This must be in areas with lots of curtailment, where there's a large resource of essentially free electricity, up to £12 per kilo. Sorry, I might have said euros earlier. £12 per kilo. This is very, very high, and it would struggle to be cost competitive. Transportation costs, again, can be up in the region of €2, and this just reflects how remote a lot of these locations are and how we would have to do continuous collection of hydrogen at different positions to get it to an end use. We look then at the regional case, and when we're looking at transportation, we end up with getting a 10 megawatt electrolyzer. When we look at heat production at this 5% offset rate, we get a 7 megawatt electrolyzer. We've kept our hydrogen production costs quite low here, and the range here reflects the fact that it's difficult for us to know exactly how much electricity will cost in 2030. So we put in a low cost price of £36 per megawatt hour and a high cost price of £72 per megawatt hour. We can see the CO2 savings tons, and this is the tons of CO2 savings, excuse me. And we can see that they are more significant for the transportation option because we're offsetting the use of a much dirtier fuel. We're offsetting the use of diesel, as opposed to in the gas grid injection, we're offsetting the use of natural gas, which is a fossil fuel, but the cleanest fossil fuel. Within our highly centralized large-scale scenarios, then we have a 27 megawatt electrolyzer or a 47 megawatt electrolyzer to meet our demands. We can see there's further small reductions in production cost, and that is driven again by economies of scale. Everything's much more efficient. Rather than building many one-off electrolyzers, we're now building large centralized ones, and our production costs, our production and our transportation costs are highly optimized. So you can see here within Belfast, 210 buses, 350 trucks, and 8 trains. And these would be the Belfast-Dublin trains. So putting some of these in context, in the transport scenario, the minimum delivered cost was £2.60 per kilo for Belfast. That's equivalent to 70, if we put that into energy content of diesel, that's 79 pence per litre. Now, we're not saying that you can go to a pump and buy hydrogen at the equivalent of 79 pence. What we're saying is that the production cost of hydrogen is not a multiple of the selling price of diesel. It is in the right ballpark. Now, this doesn't. So this is what's called a levelized cost. This is not a sale price indeed. The There is a ban on diesel buses in place, on new diesel buses, so the existing fleet will be driven. They will not be replaced with diesel only. They'll be replaced possibly with hybrid or with battery or potentially with hydrogen. It's difficult to get battery buses to do all the things that diesel buses are currently asked to do. If the hydrogen is produced in a way that satisfies the renewable transport fuel obligations, there is a subsidy. It varies because there is a marketplace for these certificates, but it's roughly in the region of £5 per kilo. So again, there is quite generous support available in Northern Ireland if the hydrogen is verified green. Some other drivers for this: hydrogen double-decker buses designed and built in Northern Ireland. And there is then a 40-ton truck technology is being rolled out in Switzerland, as James and Ian talked about earlier. On the heating scenario, minimum delivered cost again for Belfast, but Derry was not too far behind, £2.50 per kilo. It's the equivalent to 7.5 pence per kilowatt hour. Just to give context, this is more expensive than the average domestic price in Northern Ireland in 2019. It was about 5 pence per kilowatt hour. So it would suggest that if we're going to go the heating route, there needs to be greater support for hydrogen than there may need to be for the transportation route. But as we said, moving large amounts of hydrogen with a gas grid is much more desirable than moving large amounts of hydrogen by tank or truck on the roads. We have gas-fired power plants across Northern Ireland, and again, we have the salt cavern storage. So just sort of mentioning GenCon, this work is underway. There's all of the elements of this project are either of this first green hydrogen supply chain on the island of Ireland are either in place or they're currently being built right now. Electrolyser is being positioned at Long Mountain Wind Farm in County Antrim. The tube trailers to bring the high pressure hydrogen into Belfast are in place. The filling station at the TransLink depot in Belfast is under construction as we speak, and the hydrogen buses are in place driving the streets of Belfast. So this is now starting to happen, and what we're proposing is effective and efficient ways of rolling this out. Some really exciting news, just to maybe motivate some action on this, is about 3 weeks ago, ESB in the Republic here announced that the Moneypoint 1 gigawatt coal-fired power station will be closing in 2025. This was expected for some time, but what wasn't expected was the breadth of the ambition that was announced for that site. The site itself is a key nationally important piece of infrastructure. It's got a 1 gigawatt interconnection directly from Moneypoint, which is on the west coast of Ireland, to Dublin. It's the deepest port in Europe, which is currently used for offloading coal from South America. And what ESB in a joint venture with Equinor from Norway are doing is that they'll be repurposing the site as an offshore wind farm construction site. They'll be using it as the landing point for the cables that bring the electricity. They'll be sending the electricity directly to the big load center in Dublin, but they'll also then be using hydrogen production and storage to balance out that supply and in some cases exporting that hydrogen to mainland Europe. So what I've just said here in yellow is, why is this particularly important for Northern Ireland? Northern Ireland has all of these attributes, but with two additional ones. It's got salt cavern storage and it's got direct connection with both gas and electricity to Great Britain. So whatever the opportunities are for the Republic on the west coast to develop the Moneypoint site, those presented to Northern Ireland are even larger, given the offshore renewables, the storage, the interconnections with Great Britain. It's almost too perfect in terms of what is naturally available. So what's the outlook? There are many drivers, many opportunities for hydrogen in Northern Ireland, and these really get to the heart of why the Department for the Economy wanted this study done. It's plain for anyone to see that there are huge opportunities for Northern Ireland to to benefit from its natural advantages, from its manufacturing and engineering advantages, from its proximity to both the Republic of Ireland within the EU and the UK. So there really are a wealth of opportunities here, and it's our strong belief and it's our strong finding from this project that Northern Ireland should embrace hydrogen, especially green hydrogen, with both hands. So with that, I'll leave it. I'd like to acknowledge a number of people on this work. So Cian Moran and Arya Gunawan here at NUI Galway, who did the modelling work that I'm having the honour of presenting. Joshelle and James in Dublin City University. Likewise, Joshelle did a lot of the modelling work on the transportation. Everyone at High Energy and the team at Belfast Met for really bringing this whole team together in the first place. And obviously, if it weren't for the Department for the Economy, Maeve, Eddie and Thomas there, we wouldn't have had this really interesting study to do, and I wouldn't have the opportunity to talk to you today. So the full report is available at this website. If you just Google GenCom, you'll be brought there, and go to the white papers section, you'll find it. So with that, I'll hand it back over to the chair, and thank you for your attention.
Rory, once again, many thanks as always. Excellent presentation with detail. And there's a phrase that innovation is no serendipity. And as you pointed out there, you don't happen on these things by chance. You're looking at what's happening elsewhere and how we can replicate this in Northern Ireland and where the opportunities lie. What's your thoughts for commercial growth and commercial opportunity being reflective of the study you produced?
Well, I think that the opportunities, just again, let's think of what Northern Ireland brings to the table in terms of the economics and the commercial side of this. You've got a hugely important engineering sector in Northern Ireland. That's reflected in Wrightbus, that's reflected in the shipyards, and it would really be incumbent on Northern Ireland to continue to use these in a way that is sustainable into the future. So I think there's massive employment possibilities for Northern Ireland.